Okay, in this video I'd like to talk about Chapter 4 of the ONS 15454 DWDM system literature. And the first thing I want to do is remind you from Chapter 3 that we had the two different types of cards, the TNC and the TSC. And the TNC had G.29 capabilities, but the TSC didn't. And the TNC, well, if we look back on that, we can recall that G.29 is the optical service channel. So if we look at the block diagram for the TNC cards, I guess I'm not sure I see the optical service channel functionality here, but it does work with the optical service channel in any case, whereas the TSC controllers don't. Okay, and so the card is called the OSCM card. Okay, and optical service channel card, basically OSC card. It's a bidirectional channel connecting two adjacent nodes in a DWDM system. In a DWDM ring, for every DWDM node except for the terminal nodes, two different OSC terminations are present, one for the west side and one for the east side. The channel transports OSC overhead that is used to manage ONS networks. It uses a 1510 nanometer wavelength. That's important. And so this is what the optical service channel is. If I can find my red pen here, 15 nanometer wavelength. So the basic idea of the optical service channel is as follows. Let me go ahead and make a sketch of it for you. But basically we've got our WDM system, and I can take this old picture I have a picture of lambda 1, lambda 2. These are lasers. They're being driven by signals up to lambda n, and they were all multiplexed together with an optical multiplexer into a single channel. What you can do then is at this point you can multiplex in an optical service channel, lambda OSC, and this is then your transmit of the OSC. Okay, and that can occur at the transmitter, and then correspondingly at the receive end you can separate out that lambda and send the rest of them to the optical demultiplexer to their various receivers. Each channel gets its own receiver, and then this one would be the receiver for the optical service channel. Okay, and so this is the basic idea. But now what you have to do is you have to say, okay, so this is the direction of the transmission of this link here. Okay, but now what you have to do is you have to say to yourself, okay, what we're going to do is we're going to have a transmitter and a receiver at a node, and so we'll have transmit optical service channel, and without drawing all the details here, this is the transmit side. Okay, and we're also going to have a receive side corresponding, where we have the optical service channel receive. Okay, and on the other side we're going to have the optical service channel brought off to be received, and a optical demultiplexer over here for the RX. Okay, dot dot dot. And so we have the same picture over here, but now we've got the transmitter. Okay, And what this card does is it gives you this pair. It gives you this this functionality basically. I suppose it has all of this in it. Okay, and so we can see that by looking at the block diagram. Okay, well let's go to the next page. We'll turn the page on this. Let's see. There are two different cards in this dealt with in this chapter: the OSC-M and the OSC CSM. So the OSC-M has one set of optical ports and one Ethernet port located on the faceplate. Yeah, so that tells us right there that this part is included in this functionality. I wasn't sure whether to just circle the optical parts or also have the electrical parts. So it goes all the way to an Ethernet port here. It operates in slots 8 and 10. The OSC-M has 3 sets of optical ports and one Ethernet port located on its faceplate. Okay, so the card compatibility with software again gives you the time evolution. Here's Rev 4.5 of the software all the way up to Rev 9.3, and both cards are compatible with all revs of the software. In other words, these cards have been around ever since. Okay, here's the block diagram of the OSC. Let's see, this is the OSC CSM card. Yeah, it's not, this is the fancy one, I guess. 3 sets of optical ports and 1 Ethernet port. Okay, so let's see if we can figure out what everything is here. So we have a transmit side and a receive side. Okay, and this is the receive, so line receive is the input to this thing. We have a photodiode here to monitor optical power. We have to monitor optical power all through the system. We have a filter here, which is this device I drew here, which allows us to take a whole bunch of other wavelengths plus a 1510 and combine them onto a single fiber output. Okay, and this filter pulls off the optical service channel wavelength. So this is the 1510 nanometers, and this is the rest of the C-band. Okay, coming out this way. We have a tap, which probably takes off something like 1% of the power and sends it off to a receive monitor so we can watch the incoming signal. And then we allow the rest of the signal, the 99% or whatever, minus the loss of the filter, minus the loss of that tap, to come out on this COM transmit. Okay, so this is where we receive the optical service channel. Okay. Let's see, on the receive side we have, I'm sorry, this is on the receive side, the top is on the receive or the drop, and on the add section we have our line transmit, so this is the output of this node. Okay, and we have again our filter, which combines those two, it combines the 1510 with the rest of the C-band. Okay, and we have an optical switch here where we can turn the rest of the signal on, and so here's the signal that we're going to get from our optical multiplexer. Okay, and this signal then has a monitor on it, but then it also goes straight through to the line output. Okay, so here's basically that functionality that I drew. Here's the optical service channel transmission. It has a variable optical attenuator on it, and it multiplexes in with the rest of the C-band to go to the line out. Okay, let's see, the fact that we've got these controls coming from the monitor in and the through optical service channel, I guess I'm not so sure about the functionality of that. I challenge somebody to figure out what's going on there. In any case, this is the basic functionality of that optical service channel. It's working at 1550. Here's the OSC CSM. Do we have the diagram for that? No, it's a fancier version, has more ports on it. You can look up its block diagram in the documentation. I didn't print it out here for this video. Okay, so there's the optical service channel, chapter 4. Thanks.